The topic of these notes is writing and graphing inequality solutions. The essential question is, when giving an inequality solution written in inequality notation, can you graph it on a number line, and vice versa? So the instructions for these problems on this first page say that you need to graph these solutions on number lines. So all these right here, you can see that they're inequalities, and what you should know about inequalities is that there's more than one answer. So the value of x is any number in the whole wide world that's less than 5. So what I want you to do is I want you to write at least 3 or 4 numbers that x could possibly be, because you know it's any number in the whole wide world as long as it's less than 5. So go ahead and write down a couple. Write them down just right above the x. So x could be 1, because 1 is less than 5. It could be 2, because 2 is less than 5. It could be negative 12, because that's less than 5. It could be negative 1/2, because that's less than 5 also. So see right there, I have just some 4 examples, and that's going to really greatly help you when you go to graph your solutions on the number line. And the reason we got to graph inequality solutions on a number line is because there's more than one answer. So since it's any value less than 5, we don't want to sit here and write every single number that's less than 5, because that would take you an infinite amount of time, and we don't have that time, okay? Nobody's got time for that. So when you're going to graph it on your number line, you want to make sure you include this number, okay? So what I like to do is I like to put that just right smack dab in the middle. And I don't really care how many numbers you put on your number line. I just want to make sure you have that on there. And typically it might be just a good rule of thumb just to put at least a number to the right of it and a number to the left of it. So remember, numbers further to the right are larger. So if I'm going to count by ones, then this would be a 6, and then this would be a 4, okay? So I see right here it says x is less than 5. So that means 5 is not an answer, because 5 is not less than 5. So right above that 5, we're going to have an open circle. That means, hey, you can't include 5 in that. But numbers less than 5 would be like negative 1/2, 1, 2, negative 12. And look at your number line that you just wrote down. Those numbers that you wrote down as an example, that helps guide you to show which direction your arrow is going to go. So like 2, 1, negative 12, and negative 1/2, those lie to the left of this 5. So any number to the left of 5, such as these right here, that we listed, just a few of them, is a solution to this inequality, okay? So the reason you graph solutions to inequalities on a number line is because there's more than one answer. All right, read this one out here. It says that x is greater than or equal to negative 1. So x could also equal negative 1. So I want to include that in there. Okay. So again, x is bigger than or equal to negative 1. So numbers bigger than or equal to negative 1. So it could equal negative 1. Numbers bigger than negative 1 are like 1, 2, 99. 0 is bigger. So write just a couple of those numbers, because again, like I said, it helps guide you when you're creating your number line when you write down the arrow. Okay, so let's go ahead and make sure you include that number, negative 1. And I'm just going to count by ones on my number lines, but you can count by whatever increments you want, whatever intervals you want. Just make sure it's consistent, okay? So if for some reason you decide to count by 2s, then make sure you're consistently counting by 2s on your number line. You can't go sporadic and just be like random. You have to be consistent whenever you're creating a table or a number line. Okay? All right. So I'm going to count by ones on this. So the number that's directly bigger than negative 1, if I'm counting by ones, would be 0. And then 1 less than negative 1 is negative 2. Okay? All right. So remember this little symbol right here. It's greater than or equal to that. So that means, hey, negative 1 could possibly be one of the values of x. So in that case, you want to have a closed circle. When that indicates you could totally use negative 1. That's one of the possible solutions that x could be. Okay, if you are skipping this little step right here, you're more likely to mess up, so knock it off. Don't be skipping that step right here, okay? So 1, 2, 99, negative 1, and 0. Well, negative 1 was filled in. Okay, so 0, 1, 2, 99. That's all. Look at your number line. That's all to the right. Okay, so that's the direction your arrow needs to go. Okay, for the next one, it says negative 2 is less than x. So that means that x, the value of x, has to be bigger than negative 2, okay? So think of numbers that x could possibly be. Remember this? It opens up to the number that's going to be bigger. So this is going to be bigger. So think of numbers that are bigger than negative 2 and write down a couple. Don't skip this step. 9's bigger than negative 2. X could be 4, x could be 5, x could be 6, x could be 1042. Those are all bigger than negative 2, okay? So notice how I wrote them like right by the x like that? That's to show me, oh, that's what x could possibly be, okay? Don't be like, oh, I'm going to write it over here. No, you want to know what x could possibly be, possible values of x. Okay, so now create your number line, negative 2. And I'm going to count by ones, so directly here would be negative 1. Here would be negative 3. And it's going to be an open circle simply because there's no little like equal sign like up there. So we can't include negative 2 as one of the possible values of x. So in that case, you're going to do an open circle. So you see how I wrote the up here, I wrote it above the number line. Sometimes you might see it right on the number line. Oops, right on the number line. That's an open circle, so sorry. You might see it right on the number line. Open circle. And then 4, 5, 9, 6, 1042, that's all to the right. So see how it just darkens the number line? You may see that on some assessments or textbooks, okay? So just know you can write it above it or right on it, okay? But please know that that's an open circle because we do not include that negative 2. We exclude it. Okay, now this one. X is less than or equal to negative 5. So x could equal negative 5, so I'm going to write that down there. But basically it's going to be any number less than or equal to negative 5. So numbers smaller than negative 5 would be like negative 6. Because, you know, numbers smaller than negative 5 would lie to the left on the number line in relation to that. So negative 8, negative 208. Smaller. Okay. So there's a couple, create your number line, put that negative 5 on there, and then directly to the right of the negative 5 would be negative 4. If I'm counting by ones, negative 6, okay? So negative 4 is bigger than negative 5, negative 5 is bigger than negative 6. Remember, further to the right, it's bigger than all the numbers further to the left of it. All right, it's going to be inclusive because we include it because it's got that little half an equal sign there. So I'm going to close the circle. I'm going to do it right there. Close the circle. And let's see, where's negative 5? Oh, negative 5's on there, so that's why it's closed. Negative 6, negative 8, negative 208. That's all to the left. So you'll see that I wrote it right on, I darkened the number line. Like I said, that could totally happen. Or they could be like up here where it's above. It's just whatever your preference is, they're both cool. Okay, next problem is number 5. It says negative 3 is greater than x. So that means x is smaller than negative 3. Look at it. So this is opening up to the negative 3, meaning that's bigger than this guy, these guys right here that x could be. So think of numbers that are smaller than negative 3. Think of your number line. Numbers that lie to the left of negative 3 are smaller. So that'd be like negative 4, negative 5, negative 9, negative 21. Okay? Negative 3 1/2. That's smaller. Okay, so create your number line. Right smack dab in the middle, and I like to put that negative 3. I'm going to count by ones. So it'll be negative 2. This will be negative 4. And it's going to be an open circle because we don't include the negative 3 in our answer. I'm going to do it above this time. And where do these lie? On the number line. Negative 5, negative 4, negative 21, negative 3 1/2. That lies, what, to the left, huh? So that's where my arrow goes. And again, you graph your solutions to inequalities on a number line because there's more than one answer. It's this number, this number, this number, this number. You know, these fractions right here. Those fractions and decimals. Those are all possible answers that x could be because it's any number in the whole wide world that's less than negative 3. Okay, negative 3 is bigger than it. So all those numbers smaller than negative 3 are possible answers that x could be. Next up is number 6. Number 6 says 2 is less than or equal to x. Okay, so it's opening up toward the 2, so it's saying that 2 could, it's opening up toward that x could be bigger, but it could also equal 2. So right by the x, I'm going to put it could equal 2. X could also equal, let's see, bigger, 3, 4, 5, 114, okay? 93. Okay, I'm just doing random numbers that x could possibly be, because when I substitute those numbers in there, it makes that inequality, true. 114 is bigger than than 2, bigger than or equal to 2. 3 is bigger than or equal to 2, etc. Okay, let's go ahead and start the number line. Put that 2 right smack dab in the middle. Again, we can count by ones, by intervals of 1. You can count by whatever you want, just be consistent. Okay, since I see this, it could equal 2, so I'm going to do a closed circle. I'm going to do it right on top of it this time. And 114, 3, 4, 5, 93, that's all what, to the right? Okay, so the value of x is bigger than or equal to 2. All right, next one is number 7. It says -5 is greater than or equal to x. So x could totally equal -5. All right, okay, so -5 is bigger or equal to that. So possible values that x could possibly be are any numbers, smaller than -5, including -5 is also included in there. -7, -8, -14. Okay, those are just a couple. You want to write those down to help you with your number line. So put -5 there. I'm going to count by ones. I don't care what you count by, but be consistent. So that would be -4, be -6. Okay, it's going to be a closed circle because we can include that -5. It's inclusive. Okay. All right, and then -7, -8, blah, blah, blah. All to the left. Okay. All right, number 8? This one looks weird right there, okay? And don't be alarmed, it's okay, because you're going to probably see that someday. And I want to show you it now in 7th grade. This means not equal to. Okay, that's what that means. A little equal sign with it through it. A slash through it. That means x is not equal to 3. So in other words, it's any number that's not 3. So x could be 3 1/10. It could be 4/5. It could be 1003. It could be 15. It could be 24. It could be -9. It could be -1/2. It's any number but 3. It could be this, 3 1/100th. That's cool. I should have all written these over here under that x, but I just ran out of room because I got so excited. Okay, here's what your number line would look like. Same thing, put that number in the middle. I'm going to count by ones. I don't care what you count by. Okay, remember, it can't be 3, so we're going to do an open circle around the 3. But it could be any of these numbers over here in the whole wide world. Or any of these numbers over here in the whole wide world, okay? So that's what it could be. That's it. Okay, and again, inequalities, they work with fractions too, don't freak out. This says 1/2 is greater than or equal to x, so that means x could equal 1/2. Or it could be equal any number that's smaller than 1/2. So it's a number smaller than 1/2. I like to, if I know this one's positive, numbers that are always smaller than positive numbers are negative. So I could do -10. Let's see, what's another number smaller than 1/2? Smaller than 1/2 is 25/100ths. Okay. Another number smaller than 1/2 is like -1/2. Okay. All right, so let's go ahead and do our number line. Put the 1/2 smack dab in the middle. And let's see. I'm going to count by, in this one, I'm going to count by 1/2. So 1/2 plus 1/2 is 1. 1 plus 1/2 is 1 1/2. Okay, so I'm counting by 1/2. So 1/2 minus 1/2 is 0. And then another 1/2 right there would be -1/2. Okay, so it's going to be a closed circle simply because 1/2 is one of the possibilities. Okay, let's see, where are all these? 25/100. So that's the same as 1/4. So 1/4 would be like exactly right in the middle right there. -10 would be like over here. -1/2 is right there. So yeah, all these possible solutions, the possible solutions that x could be, lie to the left. Ooh. Okay. All right, the next problem says oh, x is less than or equal to 1/2. So it could equal 1/2. Remember, it's any number smaller than or equal to 1/2. So that's just like this problem up here, but we just wrote it backwards. So it could be -10. It could be 25 hundredths or 1/4. Those 1/4 and 25 hundredths are the same thing because 1 divided by 4 is 25 hundredths. We could do -12. Okay. All right, let's go ahead and do our number line right here. That's 1/2. That would be, I'm just going to copy it. Okay, so it's inclusive. We include that 1/2 in the possible answers. And 1/4, 25 hundredths, -10, -12 are to the left. Okay, your problem for the summary, what I want you to answer. Why do you need to graph inequality solutions on a number line? Why do you do that? Make sure you write down that summary or you're not going to receive points, okay? Okay, write the inequality solution represented by each number line. So this is kind of like the flip side, obviously, of the front page, where on the front page, I gave you the inequality in inequality notation, and you had to do the graph. Right here, I'm giving you the graph, and all you have to do is represent it using inequality notation, okay? So I'm going to show you how to do that. For just the sake of this, we're going to just use the variable of x, just to be standard. I don't care what variable you use, just use whatever one you want. So here's what we do. I know for sure that I have to have a 1 in there, and I'm going to use x. So here's how, with the technique and strategy I do. I start with an x, and then I write down the number that I see. And then I want you to also be able to write it the other way. So write 1 first, and then the x second, okay? All right, here's what you do. So x could be any number that is to the left of 1, including 1, okay? So that would look like this. Okay, think about that for a second. 1 is bigger than x, or it could equal it because it's closed, a closed circle, okay? So the way I do it is, what's bigger, x or 1? Oh, 1's bigger. And is it filled in? Yep, so do that, okay? So these two mean the same exact thing. I want you to be familiar with both of them in case you see it this way. I don't want you to be like, what does that mean? Because those are interchangeable, okay? You need to know both ways because you need to. All right, right here. Again, let's start off with, I'm going to do these in a different color so that you don't get them confused. So this one, number 2 is blue. X and -12. And then again, I want you to make sure you can do it both ways. Okay, here's what you do. What's bigger, -12 or x? What's further to the right? X is. So x is bigger. Okay, and do we include it? Nope. So I don't put the little half and equal sign under there. Okay, again, what was bigger? -12 or x? Oh, x is bigger. Okay, like that. Next problem, I'll do it in green. Okay, the numbers we see is -1/2 and x and -1/2. Or you could write it as -1/2 and x. Okay, here's what we do. What's bigger? What's further to the right? Remember, numbers further to the right are bigger. What's bigger? X or -1/2? Oh, -1/2 is bigger because it's further to the right. It's going to open up that way because it wants to eat the bigger number. Do I put a little half and equal sign? Nope, it's an open circle. Okay, again, what was bigger? X or -1/2? -1/2 is bigger. Okay. Next problem I'll do in pink. Okay, write down your x and your what, -5? That's not -50, sorry. Look at my intervals. 0, 5, 10, 15, 0, -5, -10. I know it's spaced kind of like dumb a little bit. Sorry, I didn't do a very nice job, but just know it's not -50, okay? All right, anyway, x and -5. And then, or we can write -5 first and then the x second. Okay, here we go. What's bigger? What's further to the right? -5 or x? X is further to the right, so it's bigger. Okay, take a second. Is it filled in? Yep, so I gotta put that little thing right there because it totally could equal -5. Okay, do it again. What's bigger? -5 or x? Yep, x is bigger and it could equal it too. Okay? Next problem, I'll do it in blue. Okay, write down 5/10 in x and 5/10. Or you could write 5/10 first, then x. And let's see, which one's bigger? X or 5/10. Oh, 5/10 is further to the right, so it's bigger. Is it filled in? Nope, so don't put the little half and equal sign there. No, no, no. Okay, again, what's bigger? X or 5/10? Yep, 5/10 is bigger. Okay, there's your answer. Number 6, I will do that in green. So for number 6, you're going to go ahead and write X and 2. Or you could write 2 first and then the X second. Okay, here we go. What's bigger? What's further to the right? Same thing. X or 2? Oh, 2 is further to the right, so that's bigger. Is it filled in? Yep, so we can include the 2 in our solutions. Okay, again, what's bigger? X or 2? Oh, 2. And it is filled in, so that's your answer. Okay, number 7. I'll do that in, we'll just do red. Number 7. Okay, write down X. And what, 130? Or you can write 130 first and then X second. Okay, here we go. What's bigger? X or 130? Oh, 130 is further to the right, so it's bigger. Is it filled in? Nope. So that's it. Don't put the half and equal sign there. Okay, again. What's bigger? What's further to the right? X or 130? Oh, 130 is bigger. It's not filled in, so don't put the half and equal sign there. That's your answer. Number 8. I will do that in purple. Oh, there's like no numbers on the number line. So I just see it's just 8 and then -8, I'm sorry. And then this would be like -7, -6, blah, blah, blah. This would be -9, -10, if I'm counting by ones. Do the same exact thing. If they throw this at you, don't freak out. Just do what you know how to do. Start with X, and we got -8. Or you could write -8 first, and then X second. Okay, what's further to the right? -8 or X. X is further to the right, so it is bigger. Is it filled in? Nope, so don't put the half and equal sign there. Okay, try it again. What's further to the right? -8 or X. X is bigger. So it's going to eat the X like that. That's your answer. For your summary, all I want you to do is the same exact thing that I've just added, make it number 9. And I want you to do the same thing we did right here, and I'm going to check your work, okay? So you see you got -3 right there. It's filled in, and it's darkened to the right, okay? So write it both ways, with the variable first and that number second, and then or write the number first and then the variable second, just like we did in these examples. And have a good day. Bye.